Hi students, I hope y'all are all doing well. This lesson is going to be on arc length and area of a sector for circles. So normally I would just do the warm up, but I'm going to skip it this time because I ran out of time last lesson that I did. So I'm just going to skip straight to the lesson. If you need some more practice with those, just feel free to email me and I will send you some more practice for those types of problems that we had in the last lesson. But this is for today's lesson. So we're going to start with arc length and how to find arc length. So here's an example. So basically we know that our radius is 10 inches and we know this central angle that we know is 75 degrees. So the way we're going to do this is we're going to set it up by proportion, and then I'm going to show you how we can set it by proportion, and then from then on we can just use a formula. So, but this is how basically you compare it. You compare the central angle with this arc, which is what we're trying to find, which is BC. So I'm just going to label this arc length or arc. And then what we're going to do is the circumference of a circle. So hopefully you guys remember what the circumference of a circle, the formula is, and that is 2 pi r. Okay? So we're just going to find, basically, to find this formula, we can cross multiply. I'm going to call this central angle something we've used before, which is called theta, which is just a variable for angles that we're trying to find. So if we cross multiply, this would equal theta times, or that angle, the 75 when we plug it in, right, times 2 pi r equals my arc length, which I'm just going to call x. Okay, this is going to be x. Okay, because that's what we're trying to find, is the arc length. Equals the arc length times 360. Okay? Then if I was going to solve for x, right, what would I need to do? I would need to divide by 360. And so this is the formula that we can use to find arc length every single time. Whatever the angle, our interior angle is, times 2 pi r divided by 360. And so you can notice that we are just comparing angles with the outer circle length, right? Because the circumference is my entire length around my circle, and this is the portion I'm trying to find. This is the portion of my entire angle that I'm comparing with 360, which is my entire angle. So that's where this is coming from and how we find this formula. So let's go ahead and do this problem. And this is a formula you're probably just gonna want to commit to memory. But my interior angle is 75. So I'm gonna plug that in. 75 times 2 pi times my r, which is 10, all over 360. And then from there, I put that in my calculator. You go ahead and put that in your calculator. I'm gonna have to pull that up real quick. Okay, hopefully you're faster than me. I realize my calculator is, I have to log into my computer in order for me to get to mine. So here we go, y'all just hang with me. So it'll give you lots of time to contemplate this problem. So, and then you can even try the ones ahead if you'd like. All right, here we go. So if you put that in your calculator, 75 times 2 times, I'm just going to do 3.14 for pi, times 10, which is my radius. And then we're going to divide that by 360. And you should have gotten around 13.083, 33333. So I'm just going to round this to 13.08. Okay? And so there we go. So let's go ahead and I'm going to have you pause the video and I want you guys to try these next two. Okay. So this is how we'd set these up. Again, that angle, we're going to use this formula again over here for both of these. So my arc length is 30 times 2 pi times 12 divided by 360. And that gives me, let's see, put that in your calculator real quick. All right, and you should have gotten 6.28 for that one. And then we also want to put our units. I meant to do that for the last one, but this one would be just kilometers or kilometers, sorry, and this one would be inches. So make sure you're putting the units as well. Okay, let's do the second one. Again, I take my interior angle and I'm just plugging into this formula. X is equal to 120, which is my angle, times 2 pi times my radius, which is 2 kilometers. And then I'm going to divide that by 360. So you should get, see if you can beat me. Okay, you probably beat me. All right, the answer is 4.1866666, whatever, repeating. So I'm going to round up to 4.19, and then we'll do kilometers. So that's how you find arc length. So pretty easy. All right, so let's do, this time we're going to find our angle if we know our arc length. So this time we know x. Our x is 9. So I'm going to set it up, and 9 is equal to, and then I'm going to do x. So I'm just still using this formula that I used. Okay, x times, that's what I'm trying to find, 2 pi r, which is 4, divided by 360, and so then I'll just solve for x from there. So I'm going to multiply by 360, and then they'll cancel out. 360 times 9 is a big number, 3,240, equals x times 2 pi times 4. So I'm then just going to divide this whole expression on this side, because if we're multiplying, right, I can divide all of these at once, right? This is just 2 times 4, which is 8 pi. So I'm just going to divide both sides by this entire thing, okay? So we'll divide this by, let's do, so you put that in your calculator. This would be, just so we can rewrite it, should be 25.12. So I'm just going to do that real quick. Okay, and so this length, right, that angle should be around 128.98 degrees. Okay, and that kind of looks accurate, right? That would make sense. That would be 128. So that's how you find the angle if you know the arc length. So let's go ahead and move on to finding the sector of a circle, and I may run out of time, so I may have to make a second video, but I'm just going to keep going as long as I can. So finding the area of the shaded region. So again, we're just creating a proportion, and then what I'm going to do is I'm going to create an equation using this proportion like I did last time. So again, I'm just going to call central angle theta. I'm going to call sector x, because that's usually what we're going to be, or the sector we're trying to find x, okay, because that's usually what we're trying to find. So again, if I cross multiply, this would be x times 360 equals theta times, this time we're dealing with area, the area of a circle formula, okay? And then again, to solve for x, I just divide by 360, okay? And so the formula that I'm using this time around is going to be my angle times pi r squared divided by 360, Okay, so this is the formula I can use every single time to find the area of a sector. Okay, so let's do an example. Let's do this example over here. Okay, so for example, if I know, all right, I know my angle is 75. I'm trying to find x, which is my sector. Okay, I'm going to plug in 75 times pi, and then my r, which is my radius, which is 10, squared divided by 360, okay? And I'm just going to put that in my calculator and let it do all the work for me. So we'll do that, 75 times 3.14 times 10 squared, which is 100, and then divide that by 360. Okay, and you should get around 65.42. Okay, and so that, this time we're going to do inches squared because we're finding area. Okay, so from there we are pretty much done. That is how you would do these problems, but I'm going to keep going. I'm going to do a couple more examples, and hopefully this will help you with your homework. Okay, so let's see. So this time we're given a pretty big angle, but that still works. So we should get a pretty big distance as well. So we have, this time x is equal to, we're just going to still plug it into this formula right here. So if you want to like write this one down as well as the one that I just showed you, definitely keep these handy as you're working through your homework because you're going to need them. Okay, so my interior angle is 270 this time, and we're going to multiply that by pi times 12 squared divided by 360. Okay, and I'm just going to put that in my calculator. Again, if you want to pause the video and try to work through these problems on your own and then check yourself, that'd probably be best practice for you. If you don't feel quite confident yet, you can watch me do a couple more and then try the homework on your own. Okay, so this again was a bigger value, which makes sense because we were dealing with a bigger angle. Okay, so you should have gotten 339.12 miles squared. Okay, and then we'll do one more or two more. X is equal to 120 times pi times 15 squared divided by 360. And then I'm just going to put these in my calculator. Okay, so you should have gotten x is equal to 235.5 centimeters cubed. Okay, or not cubed, squared. All right, one more. Okay, so this time we're given the shaded region, so we're given the sector. So this time we're going to still set it equal to, so we know x this time. And now we're trying to find the radius. It's a little different from the problem that we did before. Okay, but we know our interior angle, which is 110. Pi always stays the same. And then r squared divided by 360. Okay, and I'm just going to multiply this out. Multiply by 360. Just solve. I'm just going to solve away. So 360 times 50. And we'll get, well, that's a big number, 18,000 pi equals 110 pi r squared. We'll divide, I'm going to go ahead and divide by 110 pi. And notice my pi's will cancel over here, but they'll also cancel on this side. So honestly, those will just go away. So you just have to do 18,000 divided by 110. And so when you get that, you're going to get 163.63 equals r squared, and my opposite operation of something that's squared is my square root. So I'm just going to take the square root of that and I get 12.79. And this will be, and then give me any kind of unit. So we'll just, that is our answer. So if you have any questions, feel free to ask me. You should be able to do your homework. The homework is going to be similar to these types of questions, as well as these on this page. So you can use those examples for any help. All right, good luck. Thank you guys.